Good morning students. Welcome to 11th standard chemistry video class. We are discussing lesson 1 basic concepts of chemistry and chemical calculations. In this video we will discuss the topic balancing the equation of redox reactions. Next topic, balancing the equation of redox reactions. Let us discuss how to balance the equation of redox reactions. Here we are having two methods for balancing the equation of redox reactions. They are 1. The oxidation number method, 2. Ion electron method or half reaction method. Both the methods are based on the same principle. In oxidation reduction reactions, the total number of electrons donated by the reducing agent is equal to the total number of electrons gained by the oxidizing agent. This is the principle behind the balancing the equation of redox reaction using both the methods. Oxidation number method. First, we will start with oxidation number method. In this method, the number of electrons lost or gained in the reaction is calculated from the oxidation number of the elements before and after the reaction. This concept is explained by taking an example. Here, we are going to explain how to balance equation of redox reactions using oxidation number method. It is explained by considering the following example. Consider the oxidation of ferrous sulfate by potassium permanganate in acid medium. The unbalanced chemical equation is given here. FeSO4 plus KMnO4 plus H2SO4, which gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. For balancing the equation of redox reactions, it involves 5 steps. Let me discuss one by one. Step 1. Using oxidation number concept, identify the reactants or atom which undergo oxidation and reduction. In this reaction, oxidation number of Fe in FeSO4 is plus 2 and oxidation number of Mn in KMnO4 is plus 7. FeSO4 and KMnO4 are present in the reactant side. In the product side, we are having Fe2SO4 thrice and MnSO4. The oxidation number of Fe in Fe2SO4 thrice is plus 3 and the oxidation number of Mn in MnSO4 is plus 2. In this reaction, the oxidation number of Mn in KMnO4 changes from plus 7 to plus 2 by gaining 5 electrons. Hence, it undergoes reduction reaction. The oxidation number of Fe in FeSO4 changes from plus 2 to plus 3 by losing 1 electron. Hence, it is called oxidation reaction. It is given in the step 1. Step 2. The total number of electrons lost is equal to the total number of electrons gained. Equate the number of electrons by cross multiplication of respective formula with the suitable integers on reactant side. Here, the product Fe2SO4 thrice contains 2 moles of ion, so the coefficients 1 electron and 5 electrons are multiplied by 2. Again I repeat, the product Fe2SO4 thrice contains 2 moles of ion, so the coefficients 1 electron and 5 electrons are multiplied by 2. Below FeSO4, we are having 1 electron into 2, which is equal to 2. Hence, Fe loses its 1 electron, so why we are using 1 electron. Therefore, 1 electron into 2, which is equal to 2. Below KMnO4, we are having 5 electrons into 2, which is equal to 10. Hence, Mn gains 5 electrons. So why we are using 5 electrons. Therefore, 5 electrons into 2, which is equal to 10. Now, bring the number 10 towards FeSO4 and bring the number 2 towards the KMnO4. Hence, the equation becomes 10 FeSO4 plus 2 KMnO4 plus H2SO4, which gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. It is obtained from the step 2. Step 3. Balance the reactant and the product which are oxidized and reduced. Now, based on the reactant side, balance the products, that is oxidized and reduced. The above equation becomes 10 FeSO4 plus 2 KMnO4 plus H2SO4, which gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. In the reactant side, we are having 10 Fe, which is present in FeSO4. In the product side, we are having 2 Fe, which is present in the Fe2SO4 thrice. Therefore, the product side Fe is multiplied by 5. So, we will get 5 into 2, which is equal to 10. Hence, in the product side also we are having 10 Fe. Reactant side we are having 10 Fe. The product side also we are having 10 Fe. Hence, Fe is balanced. Next one, in the reactant side we are having 2 Mn, which is present in KMnO4. But in the product side we are having only 1 Mn, which is present in the MnSO4. Now, the product side Mn is multiplied by 2. Therefore, 2 into 1, which is equal to 2. So, in the product side, we are having 2 Mn. In the reactant side also, we are having 2 Mn. Hence, we balance Mn. Now, the equation becomes 10 FeSO4 plus 2 KMnO4 plus H2SO4, which gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. It should be given in the step 3. Step 4. Balance the other elements except hydrogen and oxygen. In this case, we have to balance potassium with the symbol K and sulfur with the symbol S. But K is balanced automatically. If you see the reaction, the reactant side we are having 2 potassium, and in the product side also we are having the 2 potassium, where potassium with the symbol K. Hence, potassium is get balanced. Already we balanced Fe and Mn. Now we have to balance sulfur with the symbol S. In the reactant side, we are having 10 sulfur atom, which is present in the FeSO4. Again, the same sulfur which is present in the H2SO4, but it is not taken into account because there only we have to balance sulfur atom. So next one, we have to balance the sulfur atom. In the reactant side, we are having 10 sulfur atoms, which is present in 10 FeSO4. In the product side, we are having 18 sulfur atoms. How we are getting 18 sulfur atoms in product side? is explained here. 15 sulfur from 5 Fe2SO4 thrice, 2 sulfur from 2 MnSO4 and 1 sulfur from K2SO4. Therefore, 15S plus 2S plus 1S, which is equal to 18S. The product side we are having 18 sulfur atoms. Therefore, the difference 8 sulfur atoms in reactant side has to be balanced by multiplying H2SO4 by 8. The equation now becomes 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4, which gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus H2O. If you check the number of sulfur atoms in reactant side and product side, they must be equal. Both the side contains 18 sulfur atoms. Hence, sulfur is get balanced. Step 5. Balancing hydrogen and oxygen atoms. In the reactant side, we are having 16 hydrogen atoms, which is calculated from 8 H2SO4, that is 18 to 2 hydrogen, which is equal to 16 hydrogen. The product side, we are having 2 hydrogen atoms, which is calculated from H2O, that is 1 into 2 hydrogen, which is equal to 2 hydrogen. Therefore, multiply H2O molecules in the product side by 8. Then the equation becomes 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4, which gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus 8 H2O. If you check the number of hydrogen atoms in reactant side and the product side, they must be equal. Both the side contains 16 hydrogen atoms. Hence, hydrogen is get balanced. The oxygen atom is automatically balanced. Hence, this is the balanced equation. Again, I repeat, 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4, which gives 5 Fe2SO4 thrice plus 2 MnSO4 plus K2SO4 plus 8 H2O. This is the balanced chemical equation. Using the oxidation number method, you can also balance the equation for redox reactions. Hence, this method involves 5 steps. Using the 5 steps, you can also balance the equation for redox reactions. Hence, we completed the topic oxidation number method for balancing the equation for redox reactions. Next topic, ion electron method. This method is used for balancing ionic redox reactions. Step 1. Using oxidation number concept, find out the reactants which undergo oxidation and reduction. So, in step 1, we have to find out the reactants which undergo oxidation and reduction. In step 2, we have to write two separate half equations for oxidation and reduction reaction. Now, let us consider the same example which we have already discussed in oxidation number method for balancing the equation of redox reactions. The chemical equation is KMnO4 plus FeSO4 plus H2SO4, which gives MnSO4 plus Fe2SO4 thrice plus K2SO4 plus H2O. The ionic form for the above reaction is given here. MnO4 minus plus Fe2 plus H plus which gives Mn2 plus Fe3 plus H2O. Here the oxidation number of Mn in MnO4 minus is plus 7. Here the conversion of Mn7 plus into Mn2 plus is called reduction reaction since gaining of electron takes place. The conversion of Fe2 plus into Fe3 plus is called oxidation reaction since loss of electron takes place. Here, in the conversion of Mn7 plus into Mn2 plus, it gains 5 electrons. In the conversion of Fe2 plus into Fe3 plus, it loses 1 electron. It is explained in the ionic form. Here we are having two half reactions. One it is oxidation reaction, next one is reduction reaction. Fe2 plus which gives Fe3 plus 1 electron. It is equation number 1. Equation 1 is oxidation reaction. Since Fe2 plus ion loses its 1 electron and forms Fe3 plus ion, it is to be given for equation 1. In equation 2, MnO4 minus plus 5 electrons which gives Mn2 plus. Equation 2 is reduction reaction. Here the Mn in MnO4 minus having the oxidation number of 7 plus. The Mn7 plus is converted into Mn2 plus by gaining 5 electrons. Therefore, MnO4 minus plus 5 electrons which gives Mn2 plus. It is given in the equation 2. Balance the atoms and charges on both sides of the half reactions. In equation 1, there should be no changes. Hence, it should be written as such. Fe2 plus which gives Fe3 plus 1 electron. In equation 2, 4 oxygen on the reactant side. Therefore, add 4 H2O on the product side. To balance hydrogen, add 8 H plus in the reactant side. From the above explanation, we will get MnO4 minus plus 5 electrons plus 8 H plus which gives Mn2 plus 4 H2O. It is equation number 3. Now the equation 2 becomes equation 3. Step 3. Equate both half reactions such that the number of electrons lost is equal to the number of electrons gained. Again I repeat, equate both half reactions such that the number of electrons lost is equal to the number of electrons gained. It is explained here. In equation 3, it has 5 electrons, but in equation 1, it has 1 electron. Therefore, equation 1 is multiplied by 5. Hence, the equation becomes 5 Fe2 plus which gives 5 Fe3 plus 5 electron. This equation is called equation 4. The equation 1 becomes equation 4. Next, equation 3 is multiplied by 1. Hence, the equation becomes MnO4 minus plus 5 electron plus 8 H plus which gives Mn2 plus 4 H2O. It is equation 5. Now, the equation 3 becomes equation 5. Now, add equation 4 and 5. Here, the 5 electrons in equation 4 and 5 get cancelled. Finally, we will get 5 Fe2 plus MnO4 minus plus 8 H plus which gives 5 Fe3 plus Mn2 plus 4 H2O. It is given by equation 6. The equation 6 is the balanced chemical equation for the given reaction. The addition of two half reactions gives the balanced equation. Hence, we balanced the redox reactions using ion-electron method or half-reaction method. Hence, we completed the topic ion-electron method or half-reaction method. In this video, we discussed two methods for balancing the equation of redox reactions, namely the oxidation number method and the ion-electron method or half-reaction method. Up to this topic, we completed lesson 1, basic concepts of chemistry and chemical calculations. In our next video class, we will start with new lesson. Thank you.